one problem statement. You have two identical eggs and a 10 floor building. Find the minimum number of drops required to determine the highest floor from which an egg can be dropped without breaking. So I have two eggs, I have to find the minimum number of drops and the highest floor from which an egg can be dropped without breaking. Now if I start searching linearly and if the egg breaks on floor number 10, then all the way you need to start from floor number 1, 2 and all the way reach till floor number 10. So you have 10 minimum drops that you need to do. Imagine if it is a 100 floor or 1000 floor building, then you have to have this 100 or 1000, right? Which is not the ideal solution. Now let's go for the binary one. Okay, binary is where you divide. Okay, on floor number 5 you go and drop the egg, and if it breaks on 5th floor, then it can break anywhere between 1, 2, 3 and 4 as well. So the second egg you will start dropping from floor number 1, 2, 3 and 4. Okay, so 4 attempts here, then 1 attempt here, so total will be 5. Okay, if it is 100 floor building, see, you will drop from 50th floor. Okay, if it breaks, then you will start checking from floor number 1 till 49. So I have to have minimum number of drops, that is 50 drops I need to check. Okay, which is also not the ideal solution. Now let's see how we have deduced to 4 in this 10 floor building. Once you understand this, you will come to know that how it is 14 for 100 floor building. So imagine that you have taken the minimum number of drops for this 10 floor building as 4. Okay, so I go to the floor number 4 and drop the egg here, and if it breaks, so if it breaks, it means it can break anywhere between 1, 2 and 3 as well. So the first drop is done here. Second drop I will start checking from floor number 1, 2 and 3. Okay, that's what I have written here. So first is done, then you will start checking from 1, 2 and 3. Okay, so if it breaks anywhere between floor number 1 to 4, you have this all the 4 drops you can check here. Now if on the floor number 4 it doesn't break, then to which floor I can switch so that I have all the 4 drops which has to be exhausted, right? So first drop is done here, it did not break. Then second drop if I do here on floor number 7, okay, and if it breaks, okay, then the third drop I can check is floor number 5 and 6, right? In that way I cover all the 4 here. Getting it? So it did not break here and it broken on 7th, so I can check whether it can be broken on 5th, whether it can be broken on 6th. So that is where, so first is done here, second is 7th, then the third is 6 and 5. So in this phase you will see the number of drops that is reduced to 3. Now on 4th it did not break, on 7th it did not break. Now what is the next switch I can do so that I have all the 4 drops I have to be used, right? So if I switch on 9th floor and suppose if it has broken, so if it has broken on 9th, it can break on 8th, right? So if you see, the total is 1, 2, then 3, then 4. Okay, so 1, 2, then 3, then 4. And in the last iteration it is like 4 it did not break, 7 it did not break, 9 it did not break, then it has to be checked on 10th. So that is what you see, 4, 7, 9 and 10. Okay, so if I go in this phase, it has to be like 4, 1, 2, 3. Then the second phase is like 4, 7, 6, 5. Then 4, 7, 9, 8. Then 4, 7, 9 and 10. Okay, now if you see this, if I keep adding this 4, if the number of drops which has reduced in the next phase, right, if I add this, I get the next floor, that is 7. If I add this 2, 4 plus 3 plus 2, I reach till the 9th floor. Then if I add this all, I reach till 10th floor. So it is n plus n minus 1 plus n minus 2 all the way till 1, I reach till finally the building number, what is the maximum number of building, right? So the formula that we come up with is like n plus n minus 1 all the way till 1, that is nothing but n into n plus 1 by 2, and that has to be greater than equal to, why it is equal to, I'll tell you. Now if you solve this, right, 4 into 5 by 2, it comes 10. So 4 is nothing but the n plus 1 is 5, 4 into 5, 20 by 2, that is 10. So the minimum number of drops that is required is 4. That's why the answer is 4 in this 10 floor building. Now imagine like if it is a 9 floor building, and if I do just equal to, right, then here if you take the minimum drop is 3 into 4 by 2, that is 6. 6 is equal to 9. No, it is not. Now if I go for 4 into 5 by 2, that is 10. Even 10 equal to 9, that is not true, right? Now if I do greater than equal to, right, 4 into 5 by 2 is nothing but the 10. Now 10 greater than equal to 9, that is the correct pick. So even for the 9 floor building, the answer will be 4. Because if you go for this 10 floor building, even if it is 5 into 6 by 2, okay, the minimum number of drop it is 5. So this comes around 15 greater than equal to 10. Even that also works, okay, because 15 is greater than 10, okay. But we needed the minimum one, so that's the reason the answer is 4. If you have understood this, then the same thing applies here. N into n plus 1 by 2 greater than equal to 100, right? When you solve this, it comes around 13.6 something. So that is why you will see the answer as 14 for the 100 floor building.